Hello, this is our continuation of Lecture 5. We've come to the portion where we have example exercises, and the topic of this lecture is sequences and summations. Exercise 1, find the terms of the sequence a subscript n, where a sub n is equal to 2 times minus 3 to the power n plus 5 to the power n. A sub 0 is equal to 3, a sub 1 is equal to minus 1, a sub 4 is equal to 787, and a sub 5 is 2,639. 9. Find the first 5 terms of the sequence defined by each of these recurrence relations and initial conditions. Part A sub n is equal to 6, a sub n minus 1, where a sub 0 is equal to 2. A sub 0 is 2, a sub 1 is 12, a sub 2 is 72, a sub 3 is 632, and a sub 4 is 2592. B, a sub n is equal to a sub n minus 1 squared, where a sub 1 is equal to 2. This time our first 5 terms run from a sub 1 to a sub 5. And they are respectively 2, 4, 16, 256, and 65, 536. C, a sub n is equal to a sub n minus 1 plus 3 a sub n minus 2. A sub 0 equal 1 and a sub 1 equal 2, and our terms now run from A0 to A4. 1, 2, 5, 11, and 26 are our values. Part D, a sub n is equal to n a sub n minus 1 plus n squared, a sub n minus 2, a sub 1 equal 1, and a sub 0 equal 1 and a sub 1 equal 1. Our terms are running from a sub 0 through a sub 4, 1, 1, 6, 27, and 204. Part E, a sub n is equal to a sub n minus 1 plus a sub n minus 3, a sub 0 equal 1, a sub 1 equal 2, and a sub 2 equals 0. And our terms running from a sub 0 to a sub 4 are 1, 2, 0, 1, 3. 17, find a solution to each of these recurrence relations with the given initial conditions. Use an iterative approach as used in example 10. A sub n is equal to 3, a sub n minus 1, a sub 0 is equal to 2. We see a sub 1 is equal to 3 times 2, a sub 2 is equal to 3 squared times 2, a sub 3 is equal to 3 cubed times 2, and we can deduce that a sub n is equal to 3 to the n times 2. B, a sub n is equal to a sub n minus 1 plus 2, a sub 0 is equal to 3. We have a sub 1 is equal to 3 plus 2. We have a sub 2 is equal to 3 plus 2 times 2, a sub 3 is equal to 3 plus 3 times 2, and a sub n is equal to 3 plus 2 to the n. C, we have a sub n is equal to a sub n minus 1 plus n, a sub 0 equal 1. We have a sub 0 is equal to 1 plus 1. We have a sub 1, a sub 2 is equal to 1 plus 2. We have a sub 3 is equal to 1 plus the sum from 1 to 3. And we have a sub n is equal to n is equal to 1 plus the sum from 1 to n, which we summarize as n times n plus 1 over 2. D, a sub n is equal to a sub n minus 1 plus 2n plus 3. A sub 0 is equal to 4. We have a sub 0 is equal to 2 is equal to 4 plus 2 times 1 plus 3. A sub 2 is equal to 4 plus 2 times 1 plus 2 plus 2 times 3. And a sub n is equal to n times 3 is equal to n squared plus 4n plus 4. E, we have a sub n is equal to 2a sub n minus 1 minus 1. And a sub 0 is equal to 1. So we have a sub 1 is equal to 1 minus 1 equal 1. And a sub 2 is equal to 1. And a sub n is equal to 1. F, we have a sub n is equal to 3a sub n minus 1 plus 1. So a sub 0 is equal to 3 times 1 plus 1. A sub 2 is equal to 3 squared plus 3 plus 1. A sub 3 is equal to 3 cubed plus 3 squared plus 3 to the 1 power plus 3, 0. A sub n is equal to the sum from k equals 0 to n of 3 to the k, which we recall from our earlier formula is 3 to the n plus 1 minus 1 over 2. In G, we have a sub n is equal to n a to the n minus 1. A sub 0 is equal to 5. A sub 1 is equal to 1 times 5. A sub 2 is equal to 2 times 1 times 5. A sub 3 is equal to 3 times 2 times 1 times 5. A sub n is equal to n times 5 times n to the minus 1, which is equal to 5n factorial. And H, we have a sub n is at 2n a sub n minus 1, a sub 0 equal 1. We have a sub 1 is equal to 2 times 1 times 1. A sub 2 is triple 2 times double 1, and a sub 3 is equal to triple 2 times 3 times 2 times 1, which is 2 cubed times 3 factorial, and a sub n is equal to 2 to the n times n factorial. 19, suppose that the number of bacteria in a colony triples every hour. Set up a recurrence relation for the number of bacteria after n hours have elapsed. Solution. Since the number of bacteria triples every hour, the recurrence relation should say that the number of bacteria after n hours is 3 times the number of bacteria after n minus 1 hours. Letting b subscript n denote the number of bacteria after n hours, this statement translates to the recurrence relation b sub n is equal to 3 b sub n minus 1. Part B. If 100 bacteria are used to begin a new colony, how many bacteria will be in the colony after 10 hours? Solution. The given statement is the initial condition b sub 0 equal 100. The number of bacteria at the beginning is the number of bacteria after no hours have elapsed. We solve the recurrence relation by iteration, finding that b subscript n is equal to 3 to the n b sub 0. Hence, the number of bacteria after 10 hours is b10 is equal to 3 to the 10th power times b sub 0, which is equal to 5,904,900,000. And this concludes our lecture.